Okay, so we want to look at the non-negative real numbers between 0 and 20 who add up to 20, right? We want to look at who has the greatest product. So here, greatest product, that's our indication of what we want to maximize, right? So we want to maximize product, okay? So product in this case, I said this in the notes, right? Let's just use the letters X and Y, and that's equal to product, right? This is the thing we want to maximize. But there's more information that's given to us, right? Do you see that we have non-negative real numbers between 0 and 20 whose sum is 20, and I want to focus mostly on things that are going to give me an equation. So when we're talking about a sum who's 20, well, using those same variables, that's x plus y is equal to 20. So in this case, this represents an objective function, and in this case, this represents a constraint. So the job of this constraint here is to help us better understand the objective function. So if you remember, we're trying to use calculus to do this. So a lot of times what we end up doing is we end up taking a derivative. Well, as it stands, if we were to take the derivative of p is equal to xy, we'd have to use implicit differentiation, right? And we would have to know the rate at which one variable changes with respect to the other, right? Do you remember doing things like dp dx and dy dx, right? It's kind of more than what we want here. So we actually want to avoid that. We don't want to have to do this here. And that's where this constraint comes in. If we can find a way to rewrite this so that our original or our objective function is only in one variable, that helps us out quite a bit. So, let's solve for one of these variables. Let's just say x is equal to 20 minus y. So that when we're over here, we can say p is equal to, and instead of x, 20 minus y times the y that's already there. So p is equal to 20y minus y squared. Now notice we have not taken a derivative yet, right? That's actually our next step. Okay, so now let's take the derivative. Let's differentiate with respect to x, with respect to y, because that's the variable that we've got, right? Had we solved the other way, which you could have, right? You could have solved for y instead of x, substituted in the other direction. That would have been okay as well. So if we differentiate, we get dp dy is equal to, and this becomes 20 minus 2y, right? Then what we want to do is we want to find our critical values, okay? So in order to do that, we set this equal to 0, okay? So that means 20 is equal to 2y, divide everyone by 2. That means y is equal to 10. Now this is maybe not an official answer yet. This is more of a claim, okay? Y is equal to 10 we're trying to maximize our product. But this is the thing. How do you know that that claim is true or not? Well, the answer is you come back here to our first derivative. So I'm going to take this first derivative, dp dy is equal to 20 minus 2y, and we're going to use the second derivative test. Why? Well, because the second derivative test is a really straightforward way to figure out if something is a maximum or a minimum. In our case, we're looking for a maximum, right? But it allows us to do that without having to do intervals of increasing, decreasing. It's kind of the shorter road to what we want to get at, right? So in order to apply the second derivative test, I need the second derivative. So d squared p dy squared, this is just going to be negative 2, right? So that when we look at this, even when we check the second derivative at y is equal to 10, the second derivative doesn't change, right? There's no variables in there. this is still equal to negative 2, which is a negative value, which by that second derivative test, that tells us y equals 10 is a local max. So that's how this goes from a claim to something that we have shown, right? This is a local maximum. This is, in fact, an answer, and I should throw, oh, we don't have units, so we don't need units on there. So how do we find our other value? Well, that's where your constraint comes in handy again, right? Our constraint was x plus y. Well, we know 20 here, x here. We know y is 10, so that means that x also happens to be 10. Okay, and those are your two numbers. It also asked us to find the sum, right? So the sum in this case, we know the sum. The sum is x plus y, right? It's 20. That works out. And the product is x times y, which is 100. Okay? All right, I'll see you in the examples.